In this video, we are going to look at some more series and parallel circuit. Here we have got a circuit with a switch. The question is asking you what is the current drawn from the battery when the switch is open. When the switch is open, we can see that this 3 and 5 ohm would be in series, and on the other side 5 and 3 ohm would be in series. So we can see that we can redraw this circuit as 8 ohm, 2 8 ohm resistors in parallel. Apply the parallel resistance formula. Do not forget to flip. So R total, you get it as 4 ohm. Then the current will be V over R total. Substitute the numbers, we get the answer for current as 6 ampere. That's the current which will be drawn from the battery. If they had asked you what's the current in each branch, then you need to write it as 3 amperes because this 6 ampere will split equally in the two branches. So each 8 ohm resistor will get 3 ampere. But here is asking you what's the current drawn from the battery. That is a total current. So that's 6 ampere. Next, 3 resistors are connected across 120 volt battery. How much total power is dissipated? Now in this case it's asking for power. So we'll use the formula V square over R. There are many different formulas for power. Depending on what's given to us in the problem, we can choose the formula. Here I have the voltage and I have the resistance value. So I'm going to use P equal V square over R, and the R should be R total. So the 60 and 60 ohm, they are in parallel. When you combine them using the parallel formula, you'll get the answer as 30 ohm. Then we can redraw and see that the 30 ohm and the two 30 ohms are in series with each other. So that means our total is 60. Just substitute the numbers into the formula for power and we get the answer as 240 watts. Next problem is based on Kirchhoff's loop rule. So let's look at it. Loop rule and junction rule. Let's look at the problem. 3 resistors are connected to 2 batteries as shown in the figure below. The current in resistance R1 is 2 ampere and R2 is 1 ampere. We will just label the loop before solving the problem. It's asking us what is the current through 20 ohm resistor. So at junction F, we will write the total current entering is equal to total current leaving. So at junction F, we can see 2 ampere and 1 ampere. They are reaching the junction. So they will add up. It is equal to I, which is leaving the junction. So I will be equal to 3 ampere. So the current in 20 ohm resistor is 3 ampere. Next, it's asking us to apply Kirchhoff's loop rule. So for that, we are going to use the sign conventions. It's asking us to find the resistance R1. So we'll take the loop, which is the top loop, A, B, C, F, A. Then we are going to put the signs for each component. So you can see for 20 ohm, I have put the left side as positive because the current is entering from there, and the right side as negative because the current is going to leave from there. Similarly for R1, if you see the current flowing through R1 is 2 ampere, and therefore the right side from where the current is entering into R1 will be positive, and the left side from where the current is leaving would be negative. So for sign convention, you have to remember current will enter from positive and leave from negative. So for resistors, when you are putting the signs for resistor, look at the direction of current. If it's entering the resistor, that side will be positive. If it is leaving the resistor, that side will be negative. I will also label the current I, which we found in part A, which is 3 ampere. Now we'll write the loop name A, B, C, F, A so that it helps us to travel along the loop. So from A to B, I have got 2 components. One is the resistor and one is the cell. So for resistor, when I cross the resistor in the direction of AB, I reach positive side of the resistor. So I'll write positive 2 times R1, which is V equal IR. So I'm trying to write the potential for R1, which is current multiplied by resistance. So 2 ampere, so 2 multiplied by resistance, which is R1. Then the cell, when we cross it, we reach negative side of the cell, so that is negative 100. Then B to C, we don't have anything. Then C to F, we have one resistor, and when we cross it, we are going to reach the positive side of the resistor. So positive, and then again remember we need to write the voltage. So V is equal to IR, the current is 3 ampere, the resistance is 20, so 20 times 3. Then F to A, we don't have anything, so we'll finish the equation equal to 0. Once you have got the equation, we can solve it easily to get the value for R1, which is 20 ohm. Another problem, but a simpler one, it's only a single loop. So what we want to find is what's the current through 4 ohm. We need to know that it's just one circuit, one path. So there is, all of them are in series. That means there is only one path, so it's connected in series. So the current will be same. We are going to put the signs for the components. For resistor, now the current direction is not given in the diagram, so I'm assuming the current in this direction. That means the current direction is put by me. If you want to put the direction opposite, you can. But according to the current direction, the sign convention, you have to check the signs for the components. For me, for 2 ohm, the bottom is positive, the top is negative, because the current is entering from the bottom and leaving from the top. For 4 ohm, the left is positive and the right is negative, because the current is entering from the left and leaving from the right. We just label the loop and then we write the loop equation. So if I go from A to B, I have got a resistor that is 2 ohm. When I cross the resistor, I reach negative. So negative I times 2. Again, we have to write the voltage. Do not forget that. So it has to be I times R all the time for a resistor. Then from B to C, when I cross the 4 ohm, I reach the negative. So negative I times 4. Then I cross the cell, I reach negative, so negative 9. Then this next cell, which is 15 volt, but when we cross it, we reach the positive side of the cell. So positive 15 equals 0. We solve it for the current and we get the answer as 1 ampere.